Hello. In this video we're going to continue the Loki project. At first I'm gonna do a small bit of recap on what happened. So we were working on the tokenizer. There were parts left. There was I think a test failure. But when I tried to fix that and looked at what is remaining from the tokenizer, I thought it would be really boring video to do at least one other video on tokenizer. So I thought I would complete that on my own and just show you how we are doing this right now. Now we are like almost doing, I think we are doing everything we did we needed to do. So we almost support most of the syntaxes now. We support structs, we support interfaces, we support three kinds of for loops we had. We support if statements, and all tests are passed. I think there was a test failure actually. Yes, there's this test failure for bang operator. This is here, not this test. So why but the other things are and the structure of the code is mostly the same. So if you take a look, we have the same set of else ifs, and actually we added this so that one of the problems in the last stream was that we tried when we reached a character that we needed to end the last token or the current token we were working on. It could be a semicolon, space, I don't know. Most of characters have this effect. We needed to check what token we are working on, what kind of token, and so we extracted all those logic into here, into this function. So it will check at the end of at the time we are going to emit a token as an identifier. We are going to check if it's one of these inside. We're gonna emit the actual token for this type. So for example, we read true as an identifier because we don't have any mechanism to differ it from other things, right? So we read it as an identifier, then if it's true we convert it to a true keyword, or false, or for keyword, or everything is just like this. So that is the recap, and let's take a look at the test failure. So it seems that we need a true keyword at last, but we are just getting a identifier true. This is actually really weird that we have this problem. So do we go into bang state? Yes. So when we go into bang state, and we are using these ambiguous thing. Oh, at the end of that is actually a nice bug, because at the end we need to also have that if thing. We need to have this because at the end of the string we also need to check for any kind of keywords, especially the booleans and stuff. So I think this is going to so what's the last one? Current token. If we have something as current token, right? Okay, I think it's cool now. So let's launch the test again. Hopefully this will pass now. Yes, so the problem was at the end of the string we also need to check before we emit just a random basically token. We need to so we need to check if it's one of these keyword types we have. So now that we have these, the tokenizer is mostly ready. There might be other operators and stuff we don't support, but these will not change how we are doing it, and we'll add them at the when we are doing other stuff. So let's start. So, and also I put the tokenizer inside inside a file, inside a module, and my module just uses that. So let's create a new where am I? Yes, so let's create a new file for Parser. So what does Parser does? So Parser basically takes the vector of tokens we already have and returns a new ASD, or I'm not gonna call this ASD because it's a scary name, so I'm just gonna call this a vector. Not a vector, it's basically a module, right? So in Loki we already know that our modules, our files are nothing but a set of declarations, right? So each file has a set of declarations. At the top it has imports, then it has probably types and functions. So that is basically it. So each file is just a set of declarations. So let's just do that. So after we get some tokens, I'm gonna parse them and create a parse. Gonna take a vector of token, let me of course import this tokens, and it will return a vector of declarations. Also in tokenizer I'm gonna make this we have this, yes, cool, and this is also a result, and this is also going to use super errors. Okay. Okay, cool. So we have this. So let's actually hook up our so actually let's do it a bit test driven like. So what I'm going to do, okay, so what I'm going to do is test parse, I don't know, an if. No, parse an assignment. Parsing a constant assign. That's the simplest thing we can parse, right? So what I'm going to have is a tokens, which is a vec of tokens, sure, tokens, vec of tokens, oh, and token. So So what does a token have? Tokens have the type. Should I make these public as well? They are. So a token is a type, has a type, token type. I think I have this problem. Better now. So this has this one. What about this? Cannot find token. Okay, normal because we don't have this. And here we can do this. So we have these tokens now, and can we do this? Should do is token type. So will it give me help or not? Then we also have this sum of the not sum, sorry, okay, of this. So everything here is fixed now. Let's say ident. It's really stupid that when I'm doing just wanting to do a test, I need to import everything. When I'm in the same file, I mean. The value is going to be sum of a string, and the string is going to be x. So for example, let's say we have x equals 2. We should be able to parse that, right? Okay, so we have x. We're going to have the type, which is token type, assign op, value is none, token is type, token type, the data, it can be anything, but let's just start with a number which is simple. So I'm gonna say not the int keyword, I'm gonna say number, and the value is going to be a sum of string from 12, for example. So we have this parse constant assign. So we have this now. Now if we call the parse on tokens, parse gets tokens and returns a result. So for the wrap and let decals, I'm gonna say. Okay, this should be also public. Use super parse. Okay, so we got the decals. Now I need the same functionality from tokenizer. If you remember, what was that? It was the equal vex function that I had in here, and I need that in there. So let me just copy this, go into parser, paste this. Okay, cool. So now that we have this, I can easily say equal vex, the variable 1 is decals, the variable 2 is going to be a vector of decals. So what is a decal? Now we need to define that. So each decal probably needs so each declaration has name. Basically, I'm declaring something as something. So at least at the top level we have only declarations, right? And declarations are constants, they're not mutable. So each declaration has a left hand side and a right hand side. So basically it has a name, which is a string. It also has a value, which is a string. It's not a string anymore, it's actually a value. So a value. Okay, so this is actually a hard part. I mean, we need to hand this value thing should be basically a polymorphic type, because it can be a number, it can be a string, it can be a function, it can be anything, and all of them are declarations. I'm gonna say expression. It has a name, an expression, which is an expression should be a trait, and it has evaluate, not evaluate necessarily. I'm gonna just say an empty trait expression. Impl. We cannot do this. Box dyn. Okay, so it's a dynamic version of decal, works on dynamic trait objects of expression. And what is an expression? And actually I'm gonna make this a bit simpler. To expert, right? I'm using do me max, by the way. Oh, actually, and I need to make this bigger. I hope I didn't. Okay, I think it's better now. And I've installed it for a day or two, and it's really nice. Especially all the idea of everything is configured. It's really nice for me. So we have the expressions. What is an expression? For example, a number can just be itself. A function. What does the compiler do about these stuff? I mean, about a random constant number. What does it do? It puts it on the binary, right? Forget about the compiler. What does our compiler, which is for now a transpiler, what should we do? For example, in case of a function, I think this is the best thing we can do for now, to have this as an expression, so we can. So for example, let's just fix this test for now. So x equals 12. What is a number? So I'm gonna have a struct called, for example, number right? It has a public value inside, which is a F64, I think, to support everything. This is public. So if I'm gonna say for I in 0 until tokens.len, what I'm going to do, I'm gonna say I have decals, which is a vec, and I'm going to return those decals. Now I'm gonna say for each token in tokens.iter, token becomes a token. For each token, for example, if token.type equals, can I get a tuple of these? Let's try to get Rust for loop. Okay, I know. Index. Oh, we should use the enumerate thing. I remember now. Okay, so we should just do enumerate. Iter enumerate. So this will give me an I, which is an index basically for our token. So if token.type is an ident, so what we should do is we should skip until we reach a token type, which is an assign. When we reach this, we should get one before and one after, which will be not necessarily one after and not necessarily one before. This is one way. There's other way. You can just start from left side and just say so get the so let's just do that. So if we reach an ident, we're going to have a current decal, which is an option of decals, which is none for now. Okay. And so we are going to have an option of decals, which is none. If we reach an ident, if current decal is none, let's go with a happy path. Sorry. So if the current decal is none, what we are going to do is going to be a sum of a declaration and a declaration has two things. So it has a name. This is going to be the token.value, and an expression which is a box of dynamic expression. So each it's harder than I thought, at least in my mind. So maybe not a trait, so maybe I deleted everything. So maybe not maybe a struct is better, and if we also have a public enum expression type so if we have expression type function number, actually in here we should infer these types now. Float 32, float 64, for example, string, character. We don't actually support character syntax, but we need. If and for the payload, I'm gonna have that public trait called expression payload, and these are going to be box values of that. This is basically just a marker. I think let me just compile this down, but it's completely generalized, and this is not going to be, so I needed one level of indirection because I need to know the expression type, but anything else about these are completely different. I cannot find a mutual behavior to model it in a trait. This is, at least for now, the simplest thing I can do. So now this number thing, we imagine this is an int. So what we will do is we create a int payload as value of i64, and we also going to implement expression payload for int payload. Now the declaration is going to have an expression. Expression is an expression. What is inside an expression? It's a type. So the expression type is an int, and the payload of that expression is a box new for now it's an int payload, and the value for that int payload is going to be zero. I know this is wrong. I know all of these are wrong, but just consider borrowing the option. Okay, so basically what we are doing, so I actually focused more on this part, and this is more important for me. So because the expression type, right, sorry, the expression type, the expression payload, and this is actually a bit, I think, good design. I think it would work for us. So now let's fix these. So this is not important for me right now, but this is important because I want the value. So what do I want to do? If the current decal is none, get this token dot value. This is the name. What about the payload we are going to have in it? I'm gonna say 0 value, right? So because in the next else if token dot type equals token type assign operation. When we reach an assign operation, so when we reach an assign operation, I'm gonna say tokens I plus 1 so I make this as safe. Also do an unwrap in here, but again I'm gonna fix this. So this will tell me next token. So what I want to do, so when I reach an assign operator, I want to take a look at the next one, just the next token, and try to infer what expression I'm going to assign. So now with this next token should become a token reference. So I'm going to say if next token, for example, is the type is token type, not int keyword, but a number, right? For example, if this is a number, what I'm going to do is say, okay, current decal should now have the payload current decal the unwrap. I assume this is also should fix dot expression dot payload dot oh, I cannot access this. I mean, that's valid. I don't know the type. I should just create a new payload. So payload is going to be a box new. Let's just make this so it should be an option, so we don't have the unnecessary heap allocate, and it's just going to be a none for now. So it's going to be a box new. It's going to be also a sum. Sum of what? Sum of int payload value is. So how we should convert string to int Rust to string str parse. So if I do stir parse, okay. another unwrap. Okay, finally. And number. Current cool. How? Why string does not implement copy? We have two questions. First of all, we need to fix this, which we will fix somehow, but the more important problem is how we can, I mean, this is actually a thing we need to think on, how we can point to this payload thing. I mean, is there a way to know the type of a box item? Rust type casting. This is actually get field of trade object Rust. Yes. Oh, that is a thing. That is a way, actually. Instead of having this payload, so you know that we have the enum. Okay, we need to do this. This is so much better, much better now. This is actually much better now. So we need to do is to do enums. Enums in Rust are really powerful. We should be able to use them. So can I use enum like this or not? First of all, X. Can we? No. So let's. So I'm gonna say payloads, payload. Yes, this is much better now. There's none of those, you know, shenanigans about things, about boxing and stuff and trait objectives, and this is much more efficient in terms of memory. So now I'm gonna just ignore all these, right? I'm gonna say payload int oh my god, this is also going to be a sum. Nice. Let it do all its work. Okay, I really like what we achieved. I cannot derive copy for these. Clone is not satisfied, of course. Why? Because derive copy. Can I do copy and clone? Because expression type has not copy. And clone. Drive. This is actually really important, this enum thing in Rust, because Rust enums are both enums and also union types, tagged unions, which is really important for us. So string does not implement copy. So what should I do? Now we should have this problem, because so our current declaration has option of decal, which does not implement copy. Okay, so when I come here in one iteration, I moved this current declaration in here. Maybe I should do clone. I don't know. Sometimes clone is just the fastest way. No, it's not. So let's take a look at the tokenizer. We had this almost same problem in tokenizer. How we did fix it? There's this current token. Okay. Parser. Let's just do the same thing we did. If let sum decal equals current decal mute how we did that in the first current token is an option none if let sum mute do we have this token, which is the token? Is it copy? No, it's not. Also, it's not a copy. What we should do in here, we should say, oh my god, why you don't work? Okay, decal. Okay, okay, nice. Which is better? Okay, better. And will you just work? Can you work? Can you compile? It's a test. Config tests. Isn't that the way you should do it? Config test module tests. parser. So if I do return cargo test, there's an error because yes, we don't have this. We need these for decals, right? So decals need debug, egg, and partial egg. Binary operation cannot be applied to expression. Equal partial equal debug. Oh, this is not a sum anymore. Okay, this is the problem we are facing, and I'm reaching the end of my video right now. But actually, good things happen this time, because actually our parser now, I think the types we created are going to work for our use case. This was really a good idea. We came up with this enum. I'm actually really feel good and confident about how this is going to work. We are going to fix this. This is not a really big issue, so we are going to fix this some way, and in the next stream we are going to continue with parser. Maybe I do some parsing on my own if I see that this is not actually a challenging thing and exciting thing. This was really nice to do on video, because it's one of my goals is to do these type system Rust design stuff on video. But I mean, parsing and making the declarations is not, a really fun thing to do, and it's kind of boring. So yeah, that is pretty much it for this video. If you like this content, continue, and if you like this content, subscribe, comment, and you can reach me on Twitter, mail, GitHub, and any place which I'm available. So thanks for watching, and until the next video, goodbye.